Welcome everybody. Good morning, good afternoon, good evening to wherever you are in the world watching Data Platform Summit 2020, sessions from the Data Platform Summit 2020. First of all, it's a pleasure being here. Obviously, I had hoped to be able to be here in India live, in person, on site, but well, a lot of it changed this last year. So right now we are doing this with recordings, but even though this is a pre-recorded video, I am with you in this session. So if you have questions, please post them in the chat window and we can and I can I'll try to answer your questions. So the title of the talk is Free Your SQL Server Data with Kafka. And I am Niels Berglund. I work as a software architect at Derivco. Derivco is an online gaming company. We are headquartered in Durban, sunny South Africa. We are, just as a side note, we are coming into summertime here now, so it's nice and warm. I have worked with SQL Server most of my life. Wrote a book around SQL Server 2005. I am a Microsoft Data Platform MVP, etc., etc., etc. It's probably worth mentioning that I'm working closely with Microsoft around certain aspects of SQL Server. Before we dive into the actual presentation, let's talk about the title of this talk: Free Your SQL Server Data with Kafka. I just want to point out here that the important bits are not SQL Server and it's not Kafka, but data. And why is that important? Well, if you look at the data landscape, if you look at our data landscape, we are every day generating more and more and more data. And so there have been some research done, and they say that in 2016 we had around 16 zettabytes worth of data, and one zettabyte is a billion terabytes. So this is a lot of data, but that is not enough. In 2025, in 9 years' time, 5 years' time from now, we estimate that we will have tenfold that amount of data. So from 16 zettabyte up to 163 zettabyte. Why do I mention that? Well, the thing is that the data that we now use, the data that we handle, we need to get insights from that. We need to be able to act upon the data. And the sooner we're acting on the data, the better. And if we are not acting, someone else will maybe do that. Your competitors, if they are handling their data better than you are handling your data, then well, essentially you will lose and you will go out of business. And if we look at how we are traditionally as SQL developers, how we are working with data, well, we persist the data. So something happens outside of the database, and then we are pushing that data into the database. A little bit like here in the picture where we're having data now coming in from left-hand side here. It may be an application, it may be an API, it may be a service, whatever generates some data. It comes into the SQL database here, and we are persisting the data. Hopefully, so I'm a SQL developer and an old school SQL developer, so if you don't work with stored procedures, you have no business being in SQL database. So hopefully you are working with stored procedures in the database. And then if you want to use the data, we are querying the data, also through stored procedures. But now, when we are in the database, we are in a high latency environment because we have transactions, we have locks, we have this, that, and the other. So our data that we are working with, it may not be that timely when we're getting result back. And if we let's look at how we are doing this, or how we used to do things back in the Derivco. So let's go into my, where do I have? I don't find, there is my Azure Data Studio. So let's say here that we have a database. So as I said, we're an online gaming company. We are capturing gameplay. So let's assume that we're having a database called Gameplay DB. Just make sure we are in the Gameplay DB. Let's select from the gameplay from a table called gameplay, because so that is now in from the PowerPoint slide. So that's now where we are inserting data into this table. If we and we are, as I said, we are using stored procedures. So let's say here that the application, the service, calls a stored procedure called PR log wager, where we're taking in some information for that particular game, for that particular wager, and that comes in, and we inserting it here into TB gameplay. Let's just make sure that we are in the right DB here as well. We are in the right DB. Let's just make sure and also create an alter to be on the safe side. And then what we have, so normally there would now be a service or an API or something like that that would call this log wager, but I haven't bothered creating that. So instead I created a stored procedure called emulate gameplay, which is doing just like that. It emulates a gameplay. We are sending in how many times we should run, what is the delay between rounds in milliseconds, and what is the max delay in milliseconds. We are defining some parameters. This is not important at all, but this is just so we can get some random numbers here. So we are generating some random numbers, and then we are calling log wager. Right. So let's run that again, and now then let's see if it works. Commands completed successfully. Let's select from TBO gameplay, and here we can now see that yes, this actually worked. We have some data coming into the database, into the table, right? Let's truncate out this table again and go back to the presentation. So that's kind of how we have been doing things throughout the years. But as I said when we spoke about data, that it is important that we are handling data in a timely fashion. So what if we want to react to the data immediately? Well, an ideal situation would look something like this, because once again, why do we want to react to the data immediately? Well, that is to get a leg up on our competitors. That is to be able to handle whatever we are doing in a more timely manner. So this is kind of what we would like it to look like. So that we have my service, my API here on the left-hand side, right? That now gets the data from somewhere, and it inserts the data into the database, but at the same time, it pushes the data into a service of sort, where we have now other apps that gets the data from that. This application here subscribes to the data from the service in real time, and it acts upon it, and then if it wants to, it can push it down back into the database. Yeah, that's kind of how we would like this to be. This is how we would like to do it, but that may not be possible, right? That may not be possible. So instead, we now have a scenario where it would be cool if we could do something like this, that the service, the API here on the left-hand side, ingests the data into the database, and in the database, think now this log wager procedure. In this now log wager procedure, potentially, we are gathering the data, we are generating an event, i.e. some JSON blob from the data, and we push it back out to this service, which we then have an application that listens to and doing this, that, and then the other. So that could be a way, if we can't change the service here to publish to the database as well as to the service, we can do something in the database because we are database developers after all. Right. So this, what about this service? Isn't that complicated? Yeah, it can be because it needs to know how to handle the data, how to handle people that are interested in consuming the data and publishing to that service, etc., etc. So, but here is where Kafka comes in. So Kafka makes this, if not completely trivial, at least kind of easy. So what is Kafka? Well, it's the de facto standard for stream processing, event processing, etc., etc. It started at LinkedIn to replace their messaging systems. It was open sourced in 2014, and after a while, the developers of Kafka at LinkedIn, they went away and created a company and founded a company called Confluent, which acts as the commercial arm of Kafka, and they are doing quite a lot of innovation on Kafka as well. So Kafka is a distributed streaming platform. We are publishing and consuming streams of records, also called events, and these records, events, are being persisted into something that looks like a commit log. And we as database developers, we love commit logs because without a commit log, we wouldn't be anywhere. So think about the transaction log in SQL Server. And why we love logs is because they're trustworthy. And with logs, we can distribute them over many nodes, so we can scale out and also have resilience. Right. Some key concepts when we're talking Kafka. We're talking about a cluster. We're talking about the brokers, and a broker is really the Kafka bit, the Kafka server, and the cluster is then one or more of these Kafka servers. So even if we only have one Kafka server, it is still in a cluster. Then when we are publishing data, we are publishing to a topic, and topic is kind of like a database table. So we are publishing the event to a topic, and where now scale, performance, etc. comes in is that this topic is partitioned. It's a little bit like a database table, a partition in a database table, but here the partition is horizontal partition and not vertical partition as we have in SQL Server with partition tables. So a partition is, in this case, is a little bit like a sharded database where we are horizontally scaling. So let's have a look at, so I have on my box, I have Confluent Kafka installed, and when you are installing Confluent Kafka, you're also getting a little nice web UI called the Control Center, where we can look at various parts of our Kafka, and we can see how we have brokers here. We have a broker ID 1, and the important bit here now for this talk are the topics. So we have here some topics, and we have two topics down here that I created, test topic and wagers, and we'll see in a second what we are doing with them. Right. We also have something called connect, and we'll come back to that just after this. So let's go back to our slides. Right, so Kafka Connect, that's a framework where we are connecting various systems to and from Kafka, and that can be databases, that can be key value stores, etc. And Kafka Connect can be deployed either standalone or distributed. We'll not talk about that here. And then Kafka Connect work with connectors, where a connector connects, as the name implies, to an external system. And we have source connectors that ingest data to topics, and we have sync connector that ingest data from topics to other system. Right. Another interesting part of Kafka is KSQL DB. It's an event streaming database. It was previously known as KSQL, and this allows us to build applications. And we are building the applications by writing normal, or well, at least somewhat normal SQL code. So we do not need to go in and write Java, Scala, what have you, but we can write SQL code that we know and love, hopefully. And this whole KSQL DB really lowers the bar to implement streaming. And we can, by writing a couple of lines of KSQL code, easily create something that can watch out for fraudulent actions, how in our case, how a player is doing, etc., etc., etc. We will not look at that in this session here, but I want to point it out for you. So if you're thinking of going to Kafka, if you're thinking of being able to react to your data in a much faster way than just with double quotes, right? To react to data much faster than in just doing queries and results, KSQL DB is for you. Right. So then SQL to Kafka. So we now have said that we can't alter the applications, whatever we had on the left-hand side that pushes the data into SQL. We can't alter that. So we need to somehow be able to handle the data inside SQL. So when the data hits SQL Server, we need to be able to take it and push it immediately back out to Kafka. Right? So what options do we have to pushing data from SQL to Kafka? Well, it turns out that there are quite a few options for this. One is SQL Server Service Broker. Service Broker was introduced in, I think it was SQL Server 2005, as an internal sort of queuing messaging system in SQL Server. You had queues, you had dialogues, you had a lot of cool stuff. And so initially it was purely internal to SQL. But in SQL 2008, Microsoft introduced something called the external activator, where you could have an external system, an EXE, listening to these queues, getting data from the queues, and then handling the data. So we could see it like my event would end up on a SQL Service Broker queue, and I would have now an external EXE picking it up from the queue and pushing it to Kafka potentially. Right. I have a sad face here for the Service Broker because we looked at it quite a lot at the Rivco, but we found that when you had high transaction volumes, when you had high throughput, Service Broker didn't really have the performance. We ran into problem with locking latches, deadlocks, etc. And also it's very much of a black box, so when things goes wrong, you don't really know what is happening. SQL CLR. SQL CLR was introduced also in SQL Server 2005. So as a side note, I think that SQL Server 2005 was probably the bestest SQL Server version ever. Well, maybe SQL 2019, but anyway, so SQL CLR was introduced in SQL Server 2005, and SQL CLR allows us to write .NET code running inside SQL Server, and we'll talk about that more in a couple of slides' time. We have CDC. CDC, change data capture, and there is a tool called Debezium, which allows us to listen to CDC and push data to Kafka. And then finally, in SQL 2019, we have something called external languages. Actually, external languages was introduced already in SQL 2016, and it supported R. In 2017, they added Python, and now in 2019 they introduced Java. And that is interesting because now we have the ability from inside SQL Server to call Java. And we could then see that we could send to Java an event, and Java application outside of SQL Server would now publish this to Kafka. Right. So these are the options. And we, as I said, we will not look at the service broker, but the other three we will look at. So let's start with SQL CLR. So SQL CLR, it's the .NET CLR, the common language runtime hosted inside SQL Server. And what you are doing, you are creating classes and methods in a language, in a .NET language of your choice. Your methods and classes can reference other assemblies. And then you compile your code together with these other assemblies into a DLL. You register this DLL with SQL Server. And finally, to use this, you are creating T-SQL objects, which invokes the methods in this assembly. And your users, they interact with these T-SQL objects. So here we can see in the upper right-hand corner, we have a SQL Server user who calls into a T-SQL method. So this T-SQL method is now the wrapper around some CLR code over here, right? So your T-SQL method calls into the CLR code. The CLR code can have ability to retrieve data from the database, and it also has ability to call out to external resources. And that's how we now will use SQL CLR in order to publish to Kafka. And I am always hitting the wrong slide here. I do apologize. So let's go back to here. And so SQL CLR and Kafka then. So the cool thing here is there is a .NET version of the Kafka client. So Confluent has created a Kafka client, a .NET version of the Kafka client, and we can now use that in our code to reference this .NET Kafka client. And we are writing a method which publishes to Kafka, calls into this .NET client and publishes to Kafka, and then we are creating a T-SQL procedure against this publishing method in your code. So, as we say in the rev code, that doesn't sound too bad, and it doesn't, but how hard can it be, and what could possibly go wrong? Well, what could possibly go wrong is that when you are creating SQL CLR assemblies, all the assemblies that the code has to be allowed to execute inside SQL Server. And if you are referencing assemblies, i.e. external assemblies, they need to be deployed as well into SQL Server. So the thing is here is that in this Kafka client code, there are certain things. So even if I tried to deploy the Kafka client, the Confluent Kafka client directly to SQL Server, it would moan because there are certain things that this client is doing that is not allowed. The other part here is that the .NET Kafka client uses a C or C++ DLL, which it loads at runtime. So if I now were to use the .NET Kafka client, I would also need to deploy this librd Kafka DLL into SQL Server. And that is a no-no because, well, this is a C or C++ DLL. It is unmanaged code. It is not .NET. So basically, I can't create it as an assembly. So however, the saving grace here is that there is in the .NET Kafka, in the Confluent.NET client, there is a way to load this librd manually. So what we would do is we would take this librd DLL and the other DLLs that it uses and put them in a directory that SQL Server can can call, and then it would work. So what to do about that stuff that we're not allowed to do in SQL Server? So let's have a look at some code. Where is my Microsoft Visual Studio? It is there. So here I have now a project. So here is my, on the right hand side here, Kafka SQL CLR producer. That is the code that I write in order to publish to Kafka, and that then in my code I have two methods. Post message, this is the method that will be exposed to a T-SQL object, and then I have the method send message, where the send message is now an interacting with the .NET Confluent.NET Kafka client. So you may now ask, so well, you already said that you can't do this. I can't take the .NET Kafka client and deploy it straight into SQL Server. You're absolutely right. Fortunately, the Confluent.NET Kafka client is open source. So what I do is I take the open source, right? I take all the source code, and then I exclude the things that we cannot do in SQL CLR from the source code. Unfortunately, the things that are excluded that we cannot do has to do with consuming messages, and we are not interested in consuming messages. We are purely interested in pushing messages out from SQL Server. And then I take this, I compile it, and I compile it into a DLL that then my code references over here, right? Then I compile everything, and life is potentially, hopefully, good, right? So then, so we said that this librd thing, yeah, so we're calling the library load method, and life should be good. So, okay, cool. Let's go back to our code and see. So now what I have done, hopefully, is that I have compiled my assembly, I have compiled the Confluent.NET client, and I am now ready to deploy. So let's run this to make sure that we are clean. So now I'm saying here that I want to create an assembly that I call Kafka Producer. That is just a name, but anyway, and I'm doing it from a path that SQL Server has access to with a DLL. And when I run that, that will work, fortunately. So we say and select start from sysassemblies, and now we will see here how I have my Kafka producer assembly, and I have that Confluent Kafka CLR assembly. And why that ended up in this database is that Confluent Kafka SQL CLR assembly is in the same location as this DLL. So with SQL CLR, if you have a reference and you are deploying from a file path, SQL Server will take all the dependent assemblies with you when you are installing. Right? So then, having done that, we can now create a procedure here which is doing the actual publish to Kafka. So we're calling it publish to Kafka CLR. We're sending in some information, what servers, where to find Kafka, which topic we're talking to, this path that we discussed in order to be able to load librd Kafka DLL, if we have a partition key, and the actual message as we are defining as an nvarchar max. And we are using that then from the Kafka producer, the Kafka SQL CLR producer, Kafka producer namespace and class name, and the method. So let's run that, Cool. So we have now created this procedure. Let's see if it works. So now what we are doing here is we're just testing this by calling publish to Kafka CLR. We're saying where this server sits. We're saying what topic to publish to. We're saying where librd path is, partition key, which is not really necessary, and then the actual message that we want to send. And when we are publishing to Kafka, the Confluent .NET client gives you back an offset. So where in this commit log did your message end up, right? So let's call this. And the demo gods are with us because I got an offset back and no error and saying that we ended up at offset 0. Right, cool. So in that case, let's go into Control Center, go into my test topic, go into Messages, and say an offset of 0. So now we have every message from an offset 0 and upwards. And when we are looking at this, let's just take off a lot of stuff that we're not interested in. And here we can now see my message, hello world from SQL CLR. How cool is that? All right. So we have now tested this, and we have actually created we have posted an event from inside SQL Server to Kafka. Now to take it to its completion. So now what we want to do, right, is we have the publish to Kafka CLR procedure. Right? What we want to do is now use that procedure so we can publish an event from gameplay. So we are creating what we're calling an hook point procedure. In other words, this procedure that we're creating here will be injected into the code path of that log wager procedure, and this procedure, generate and publish wager event, will do exactly that. It will create an event from incoming data. It will create it in an JSON format, and then it will call that publish to Kafka CLR procedure. So as we can see here, so okay, cool, DBO generate publish wager event. We are getting some settings to know where our Kafka cluster is, what topic, etc., etc. We are generating the event. We're saying it's a JSON blob, and we don't want an array wrapper because well, this is just one event, and then we're calling publish to Kafka CLR. Right. Now we are hooking it into the log wager. So after we have inserted into gameplay, we are now calling generate and publish wager event, right? Which will post this to Kafka. So let's run that. Cool. Let's make sure that we don't have anything in gameplay. We don't. So now let's test this by calling pr emulate gameplay. Don't forget, pr emulate gameplay calls that log wager. We're running that, and commands completed successfully. That's awesome. Let's select from gameplay, and yes, we do have some data in here. Let's go to Control Center, and let's look here in the wagers topic, messages. Let's look at an offset from 0, and here, how cool is this, guys? Value event key headers, offset partition. I'm not really interested in this. User ID, yeah. So let's look at that. And here we now have data. So the events came in as JSON blobs. Looking something like this, and Control Center is smart enough to see the sort of the schema for the value for the message, and saw that we have event type ID here, we have user ID, game ID, wager amount, payout amount, etc. And when I'm saying retrieve this now from the topic, it exposes that in a relational fashion. If you, however, were to consume directly from this topic, you would still get it in a JSON format, JSON blob, and you would need to handle this in one way or another, right? So 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 what have we done now? Well, let me truncate out the data here. So now what we have done is we have created a procedure that publishes to Kafka. And that was published to Kafka CLR or whatever we called it. And then we have created the hook point that hooks into the log wager process, log wager procedure, where we are generating the event and calling publish to Kafka CLR. That's cool. I don't know about you, but I think that's cool. So now, so that is SQL CLR. Let's go back to the slides here. So we have seen this, how we're creating an assembly and a procedure. We have talking about hook point procedures, and that's that. So we have seen all this already. Now, okay, cool. So if you are now on, well, live listening to the recording, if you have questions about SQL CLR, please feel free to post them and I'll try to answer them as we go along. Cool. Now, um, next thing then, change data capture is, well, change data capture is it's kind of a design pattern that where we can track data that is changing, and we have different ways of implementing this. Log scanners, etc. SQL Server supports CDC, and together with CDC, we have something called Debezium, which is an open source distributed platform for change data capture. And it listens to changes in your underlying database, and it publishes those to Kafka. And we have connectors here for various databases. And these connectors are deployed to Kafka Connect, which we spoke about before. Right. So what we do, so the MS SQL connector is monitors and records if something is changing, obviously as it's CDC. However, we need to enable CDC both on the DB as well as on the tables. We need to configure the connector so it knows what to do. And when we're doing that, topics is being created for the tables that we are interested in listen to changes for. I will say this up front. So CDC may not have the best performance ever in SQL Server, and it can have a negative throughput impact. We saw that when we were doing POCs for CDC in our environment. But I mean, so we have environments where we're doing thousands and thousands of events per second, and we saw that CDC had an impact on the throughput. That is not to say that that you can't use it. So we will not use it for high throughput transactions, right? So let's go back to SQL and let's get back to here. So let's see that we're in the right database. Let's truncate out my gameplay. That is cool. Let's see if we have something. Let's change that where name equals gameplay DB. Cool. So let's run that. Yeah. Okay, so it's probably good to say that this is a string. And CDC is not enabled, right? So what we're doing is we first are enabling at the database level. So x-axis sp CDC enable DB. That's cool. And then we are enabling it on a table level where we're saying that I am now enabling it for TB gameplay. This will spin up a couple of jobs, and this seems now to have worked correctly. That's fine, that's cool. Let's just be sure. So let's run this again. And now we can see, yes, we are enabled. That's cool. All right, that's good. Right, so now what we need to do is to configure these connectors, right? So when we are configuring connectors, the Debezium connectors, we can do it using curl, curl, or we can use Postman. I'm a little bit lazy, so I'm using Postman. So we can call here what I call get install, a get method to see what connectors are installed. That looks a little bit like this, connector plugins, and it's a get request. So let's run that. And we can see here that on a default Kafka Connect, we have quite a few different connectors. And one of those connectors is our friend, the SQL Server connector, right? So that is now installed in Kafka Connect, and we can use it. Are any connectors configured? Right? We are seeing, since I'm running this on my own machine, we can see that we have local host, and we are going against port 8083. And this gives us back nothing because we don't have any connectors enabled at the moment. So let's do that. Let's create a connector here. So this is the code. What you see here is the code to create and enable a connector for SQL Server, where we are pointing out here that which class it is. That's the Java code from the Debezium. Where is my database? Port, user, very secure password. Which database is it? This server name here, gameplay server, that is just a name. That has nothing to do with your actual SQL Server name or SQL Server instance. It is just a way to be able to differentiate different connectors, etc., from each other. And then this is the table that you are interested in. If you're having multiple tables, well, it's a comma separated list. And then finally, here, where is the broker? What is the broker? So let's do this. Let's run this code and hope that it works. So we're going to send. And then we're getting a something back. We're actually getting that we have created it. It looks good so far. Just be aware that this is somewhat asynchronous. So you are sending off this create the connector, and it kind of returns immediately. It may very well be that, and in the meantime, now in Kafka against SQL Server, there are stuff happening. And that stuff can now potentially go wrong, so that so by just getting what we see here back doesn't necessarily say that life is good. And so what we can call here is get connector status, where we are saying, right, we're connecting to localhost connectors, the name of the connector I created, and then status. Let's run that. This should have been a sufficient time to see if something goes wrong. And this looks now good. This is normally where I fail in demos, and yeah, so far so good. Let's run it once more just to ensure Yeah, this looks good. Cool. Now, if we go in here and let's go back to our control center, which we have here, and look at topics. We can now see that we have some topics automatically created for us. Gameplay server for a couple of tables that we are not interested in, and the DB history gameplay. These topics here holds metadata for your server for a couple of tables. Notice that the actual table that we are interested in is not in here. Not yet. That won't happen until we ingest something into the table, because at the moment the table was empty, right? So if it had been data in the table, we would immediately have seen that data and there would have been a topic for the table. But as it was empty, nothing there. So let's do it. Let's do it this way. Cool. What I'll do, so since we are now CDCing, we don't need a hook point anymore in our log wager procedure. So let's take that away. So now it's what it was like in the very beginning. Let's make sure that we don't have any data there. And now let's execute emulate gameplay. And that executed successfully. We have here three entries. Awesome. So let's go back to control center here. And now notice here we now have the table, right? So let's take that messages offset 0, and now we have 3 entries here times headers key, and we can see here we have quite a lot of data in here now, right? And we have payload and things and things and things and things. But important bit here, we now have data. We have, by using CDC, we have ingested some data into the TB gameplay table, and that has immediately, or almost immediately, been now pushed to Kafka SQL CLR. But once again, as I said, be aware that this can have negative performance impact on your database. Okay, so we've seen that. That's cool. Right. So once again, we have now seen the Debezium, how we created a connector, how we enabled CDC and configured the connector, and then by having all this done, when we are ingesting data into TB gameplay, that data ends up in a topic. I will just go back and do some cleanup here so we're not messing stuff up. So let's start with deleting my connector. So I'm taking it away completely. That's cool. Let's then disable the CDC, both on table and on the database, and let's truncate my TB gameplay table. Ensure that it is truncated, and it is. Cool. Now then, the last thing, once again, if you are listening on this sort of live or recorded live, if you have questions, please post them in the chat, and I'll try to answer. Right. Then the final thing here, which with what we can use to send to Kafka from SQL Server is the SQL Server Extensibility Framework. And as I said, in SQL Server 2016, R was introduced. So from inside SQL through SQL commands, you can execute an R script sitting in the R engine somewhere outside of SQL Server. And if you want to read more about that, I have actually written fairly extensively on my blog around this. Right? Then in SQL 2017, Python was introduced, so you can, in SQL 27 and above, you can now execute T-SQL code that calls out onto Python to the Python runtime outside of SQL Server and executes Python code. Right. And then finally, in 2019, SQL Server 2019, Microsoft introduced Java as an external language in the extensibility framework. So now, once again, you can from inside T-SQL call out to a Java virtual machine, the Java runtime, and execute Java code in that runtime. Think about that. And think about this. Did I just say Java? I mean, Microsoft and Java, they many years ago, they did not get along at all. But, well, things have changed. So yes, we can now call Java from Microsoft's flagship product, because I still think that SQL Server is Microsoft's flagship product. Cool. So these are Python and Java are called external languages. It means that they are external to SQL Server. They do not run in the same memory space or process. So in that respect, they are quite opposite to SQL CLR, more similar to extended stored procedures. And we need to, if we want to do this, we need to register the language in the database. And after we have registered, we are executing into this external language using a special procedure, sp execute external script. Right. And the architecture looks something like this. Yeah, let's not. So we are executing the external script. If it is R and Python, we have a process that knows that it's R or Python and pushes it to the relevant R and Python installation. For Java, we are going more or less the same way, but in this case, we need to have point out to SQL Server where Java is. Right. Code, when we are writing Java code, the code needs to be written in a specific way. And to make it easier to write Java code, Microsoft has created an SDK, which your code needs to inherit from. And the class has a well-known method called execute, which SQL Server will call into. So your class needs to implement to inherit this the Java SDK, and it needs to have an execute method. And by having this SDK, we're getting helper classes for parameters and data sets, etc., etc. Yeah, let's not go. Okay, yeah, actually, let's look at this code here on the left-hand side. So here is now some Java code example where I'm saying that I want to use the Java language extension, which is the SDK. I'm using a linked hash map for parameters, and then my class extends this, which is the SDK. And then I'm doing certain things. I have the execute method where we're sending in a primitive data set as an input, and that can then take input parameters. Actually, that can take input data, result sets, and the linked hash map here is for parameters that is being sent in. And then we are reading this stuff out and doing things with it. Right, so let's go into here and let's see what we have running. So select the DB name, yes, 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 yes. Let's see if I have created everything. Yes, I do have, right? So I have already registered Java as an external language. And let's see if I have registered, right, I have already registered the Java SDK. And I also have here a test, some test Java code that was more or less what we saw in the slide. So now to test the code, I'm doing this. I'm declaring two parameters. I'm calling sp execute external script. I'm saying that the name is Java. I'm calling into the package called SQL and the class called Java test1, and that will then make SQL Server immediately look for the execute method, and we're sending in these two parameters, which are P1 and P2. And if the demo gods are with us again, which they are, we are now getting just a coming back out that X was 21 and I was 21. And that obviously then gives us the answer to all questions in the universe 42. Right, cool. So then what we can do here now then is to write some, so Kafka is essentially Java. So the only thing we need to do in our code when we are writing our code is to use the Kafka Java client, which I should have here somewhere. So here's my code. Yeah, we can see here that in my project code, in my project settings, I'm saying that I have a dependency on org Apache Kafka and the Kafka client and the version. And by doing that, everything will be handled for me. It's nothing really, I don't really need to do anything. I don't need to do anything like I did with the CLR, etc. And my code is here, and I don't want to go into the code right now, but so I have now compiled this into a jar file, and I can now start to I can now deploy that to SQL Server. So we so my all my so my publish code is in this library or is in this jar file. And so I'm creating an external library, Java, well, Java and Java, published to Kafka. We run that. When I'm now look at sys external libraries, we're seeing Java published to Kafka. I can create now, I can now execute here my external script where I am Kafka publish SQL Kafka. That then points to the execute method. I'm retrieving some settings, and I'm just testing this by sending in hello world Java. So let's try that and see what happens. Cool, I'm getting some warning messages here, which is okay, it's not too bad. Let's then go into my control center. And let's look at topics. Let's look at test topic because that's what I just want. That's what I posted to. Let's look at offset. And here now, boys and girls, this looks like it has actually worked. And here we're now seeing hello world Java. How cool is that? So we have now, from inside SQL Server, used external languages to publish to Kafka. So what then remains to do is to, let's do it this way. Sorry. So what we now then do is we are creating a procedure called publish to Kafka Java, where we're taking an event ID, we're taking a partition value, and we're taking a message. So we're running that. Cool. And let's just make sure that this works as well. So we are calling publish to Kafka Java, right? And going back to control center. Let's just refresh here. And we will look at messages. 0. And this is now what we just sent in. Cool. So our proc also works, which is very, very cool, actually. So what then remains to do here is that we are now changing this my generate and publish wager event that initially called SQL CLR. Right? So we are then changing that to publish to Kafka Java instead. And then we are changing the log wager, because I think that for the CDC I took out this generate and publish wager event. So we're just ensuring that that is back in. Cool. And truncate out my table. We shouldn't have anything there. And now we're saying emulate gameplay. And this will take a little bit because we're getting those warning messages that we had before. But for once, I'm happy to see warning messages because that kind of indicates that this works. Let's go into my control center, topics, wagers, look at messages from an offset of 0, and take off some stuff. And here we now have where we're looking at the event time. What should we take off? Event type, user ID. Yeah, okay, cool. Make it a little bit more readable. And we can now see that the 3 top ones here. So this is UTC time, and this is now when I recorded this. So these are now my 3 new entries into this topic. Cool. So we have now, we have seen that, we have seen that, we have seen that, we have seen the hook procedure. And so now, once again, data comes into SQL Server, it hits the log wager proc, and in that log wager proc, we now have a hook procedure that takes the data, generates the event, and publishes it to Java. Once again, if you have questions about Java, please, and you're online in the live recording, please publish post to the chat window, and we'll try to discuss what is happening here. So to finally done. Right. So why are we doing this? Yes, because we want to get data out of the database in near real time, and we don't have any other ways of doing that. Sure, if you can change your service, etc., then life is good. Do that. But if you can't do that and you still want to get data out of the database in real time, then we have now seen three ways of doing that, and that is through SQL CLR, CDC Debezium, and then extensibility framework and external languages. And well, Apache Kafka is the de facto standard for event streaming and stream processing. Sorry, I apologize. Right, so thank you guys. If you have any questions, please post them in the chat. Here are contact details for me if you want to chat, do more after the this summit. Please reach out to me. And then we want to thank Microsoft because they are doing a lot here for data platform geeks and SQL Server geeks. I want personally to thank data platform geeks and SQL Server geeks for arranging this awesome conference. And then finally, you can win prizes, right? So even though this is virtual, you still have a way to winning prizes. So post a selfie with the hashtag DPS 2020, give session conference feedback, go to sponsor and exhibitors in the lobby, and then follow Data Platform Geeks and Data AI Summit on Twitter. Thank you, guys.